Okay. Evaporation is an indication of how much at a certain temperature would have evaporated of a substance. How fast something evaporates. Né? So kom ons sê ons het hierdie 4 stowwe by dieselfde temperatuur. Watter een van hulle gaan die vinnigste verdamp? Chloroform. Why? Because it has the weakest intermolecular forces, so they are the easiest to overcome. Okay? So as intermolekulêre kragte swakker is, het hy 'n hoër verdamping. Okay, so it's almost the opposite of boiling points. Hoe hoër iets se kookpunt is, hoe laer gaan sy verdamping wees. Does that make sense? Yes. The higher a substance's boiling point is, the lower its evaporation rate will be. Okay. En dan oppervlakspanning, wat dink julle, hoe sterker die intermolekulêre kragte is, hoe dink julle sal dit die oppervlakspanning beïnvloed? Sal dit sterker of swakker word? Weet julle wat oppervlakspanning is? Have you guys seen, sometimes when it rains, then a raindrop will fall on the water, and then it will look as if it's running on the water. Have you guys seen that? Voordat hy so al wegval. Nog nooit nie? Crazy. Okay. Another thing that is an indication of surface tension is droplets. Nee, water maak mos mooi druppeltjies. Julle ooit daai clovers in julle tuin gehad, daai kappertjie blare. Dan 'n waterdruppel kan soos op dit rondhardloop. Dit lyk soos 'n pareltjie, nee. Because water has quite a strong intermolecular force. In other words, it has quite a strong surface tension. So in plaas van onthou water is 'n vloeistof, hy suppose om plat te loop, né? Maar daai intermolekulêre kragte hou hom in 'n bubbeltjie. Now, if you have acetone at home this afternoon, try to form a little droplet of acetone. Jy gaan sien, dit is nie onmoontlik nie, maar hy gaan nie 'n mooi druppeltjie bymekaar maak nie. Hoekom nie? Want acetoon is 'n polêre molekuule en hy het net dipool kragte. So dink fisies daaroor, die goeters is nie so sterk na mekaar toe aangetrek nie, so hy maak nie so sterk 'n druppeltjie nie. Another indication of this, but we are not doing it for your practical, is a meniscus. You guys know what a meniscus is? Hi guys, you're going through life blind.
We only know what you tell us.
No. Julle sal sien meniscus is in julle notas, maar julle gaan nie meniscus doen in julle praktiese nie. Okay? I can't believe you guys have never heard of a meniscus. If you look at a glass of water and you look at it level and you look at it from the top, you will see that it climbs a bit on the edges. Dis omdat water 'n sterk intermolekulêre krag het. So it bonds together and it climbs against the sides. 'n Ander ding wat jy ook kan doen, het jy al daai gedoen wat jy soos water gooi totdat dit so half 'n hobbeltjie maak in 'n glas. You seen that? And then you will almost try to push it as far as you can, and then if you add one more droplet, then the surface tension breaks and it all spills over. Dis al 'n aanduiding van hoe sterk iets se intermolekulêre kragte is en hoe sterk sy oppervlaktespanning is. So if you guys have a big issue with mosquitoes at home, fun fact, mosquito lê hulle eiers op water, and then hulle broei daar uit. Wat is die Engels vir uitbroei?
Really?
Like the egg goes open and the mosquito comes out. Wat doen is dit? Ja, they hatch on the water. So a mosquito lays its egg on water and then it hatches on the water. As jy al daai mosquito op een slag wil verdrink, dan gooi jy net 'n druppel cyanide seep in 'n poeltjie water en dan sak hulle almal af en dan versuip hulle. Ek jokkie vir julle nie. Because what happens is if you have a body of water, this is seen from the top, then there's surface tension. So what a droplet of sunlight liquid does is it breaks the surface tension and that goes out. So dan verswak jy die oppervlaktespanning en dan gaan al die muskiete verdrink.
I'm gonna do that.
I'm dead serious. When we moved into our house in George, so George it rains all the time, I looked for every single puddle in the backyard and I threw sunlight liquid in there. I'm like, no mosquitoes in this house, not for me, thank you.
Did it work?
I don't know, I didn't have a lot of mosquitoes, but I didn't have anything to compare it with. So, who knows? Okay, goed. So 'n oppervlaktespanning, stem julle saam, hoe sterker die intermolekulêre kragte is, hoe sterker gaan die oppervlaktespanning wees. So let's quickly recap those three. The stronger the intermolecular forces, the higher the boiling point, the lower the evaporation, and the higher or the stronger the surface tension. So let's do this. Let's say intermolecular forces are increasing. Né? What will happen to the boiling point? It will also go higher. Né? What will happen to the evaporation? It will be lower. What will happen to the surface tension? It will become stronger. Aan die ander kant, as ek nou weer dit vergelyk met iets wat 'n laer intermolekulêre krag het, wat gaan gebeur met die kookpunt? It will decrease. What will happen to the evaporation? Dit sal weer hoër word, né? And what will happen to the surface tension? It will become weaker. Okay, so in julle prakties volgende week gaan julle verskillende toetse doen op hulle and then you should see that happening, né? So as jy nou die kookpunte van jou 4 verskillende goeters toets, dan behoort jy te sien dat water die hoogste kookpunt het en chloroform het die laagste. Jy behoort te sien dat water die laagste verdamping het en chloroform het die hoogste. En jy behoort te sien dat water die sterkste oppervlaktespanning het terwyl chloroform die laagste het. Okay.
Should we know anything about bond length and bonding?
No, I'm not going to look at that now. This is what you need for your practical. Okay, then solvability. Solvability isn't difficult, it's just different. Soortgelyke stowwe los op in soortgelyke stowwe. What does this mean? It means if you have a polar thing that you are throwing into a polar thing, then it will dissolve in there.
How is it, for instance, like oil and water?
Good example. Why doesn't oil and water dissolve in one another? Because they have different types of intermolecular forces. Okay, goed, so water het waterstofbindings, terwyl olie dink ek het net London-kragte. So that is why oil would not dissolve in water. Do you guys understand? Okay, so wanneer julle hierdie toets gaan doen, gaan julle verskillende stowwe probeer oplos. Julle gaan jodium probeer oplos. So you're going to have your 4 test tubes, one with acetone, one with chloroform, one with water, one with ethanol. And you're going to see in which one does iodine dissolve. Now I can tell you guys, you know that an iodine molecule looks like this. No? Similar is linear. You see that? You see it's symmetrical. So what type of a molecule will this be? Non-polar. So what type of intermolecular forces will we find between non-polar molecules? London-kragte. Nee? Okay, so keep that in the back of your mind. Non-polar. London forces. En watter een van hierdie stowwe dink julle gaan hy oplos? Nee? In?
Chloroform?
Yes. Why? Because light dissolves in light. Okay. So julle gaan sien hy gaan nie oplos in die ander drie nie. Okay, then the other one that you're going to taste is table salt. Now this is one of those things, eintlik is daai mos 'n ioniese binding, né? It's ionic bonds. But do you agree that ionic bonds on this table is closest to dipole-dipole, né? So we're going to treat them as dipole-dipole bonds for this practical. Want ons is nie nou besig met ioniese stowwe nie. Okay, so we're going to treat them as polar And the same with potassium permanganate, which is the other one that you're going to do. Remember, that's the one that's nice and purple? Onthou julle, die kalium permanganaat. We did that thing last year where I showed you the diffusion and dan versprei dit eweredig deur die hele ding. KMnO4. This is also actually an ionic salt. Both of them are ionic salts. But for the sake of this practical, we are going to regard them as polar. Okay. So in wat gaan hulle oplos? In water en in ethanol, né? You'll see that everything dissolves in everything, but to a lesser degree. So if it is polar in polar, it will dissolve completely. But if it's polar in non-polar, you'll see some of it dissolving, but not a lot. You see that? Yeah. Yeah. Okay, guys. And that's it for the practical.